Hey Spartans, Miss Hester here. Hey! Okay, bye. Go away. Oh, got it. Okay, bye. All right, we're going to be classifying numbers today, and we're going to start with a Venn diagram that looks like this. You've probably seen these Venn diagrams before. And what's going on here is on the left side is everything that dogs basically do, and then on the right side is what cats typically do. Now, things can be different, but this is for a typical dog or cat. And what we would find in the middle here is what they both have in common. So let's see. For example, click. Dogs bark. They go for walks on a leash. They chew things up. They usually come when you call them, and they like to play fetch. Now, that's not every dog. We're just talking about your typical dog. Now, cats, they'll meow, although I have heard one bark before. They can climb trees and fences. They scratch things up. I know my cats do. They don't like to come when called, unless you're opening a can of cat food. And they like to hunt, although my dogs like to hunt too. So this is just typical cat, not your everyday normal cat. Now, in the middle here is going to be what they have in common. Let's see what it is. They both have fur, hopefully. They both have 4 legs, hopefully. They're definitely both mammals. And they like to play, and they have tails. Even the ones with the little stubby tails have tails. So this is your traditional Venn diagram. Okay, now what I'm going to show you is like what's on your paper. But don't write this down. This isn't what we write. We're going to talk about a nested Venn diagram, like those Russian nesting dolls. First, we're going to start with mammals. Now think about all the mammals in the world. You got elephants, dogs, cats, horses, lemur monkeys, a sloth, a whale, a dolphin. I'm not sure what a platypus is, but I believe it's a mammal. So there's all these different mammals in the world. Let's get more specific. What kind of a mammal are we talking about? Let's talk about dogs. Now, are all dogs mammals? Sure. But are all mammals dogs? No, we got different types of mammals. So anything inside the dog circle is going to be a dog. Anything outside the dog circle is not a dog, but it is a mammal. Let's get more specific on our dogs. Labradors. Okay, are all dogs Labradors? No, we got German Shepherds, Great Danes, Schnauzers, Corgis, Mutts, all kinds of dogs. Greyhounds, Huskies, you can name any kind of dog, but we're talking specifically the Labradors. Now, are there specific kinds of Labradors? Sure, you got chocolate lab, white lab, black lab, yellow lab. There's all different types of Labrador colors, and they would be in the middle here. Now, all labs are dogs. Are all Labradors mammals? Yes. You know why? Because they're inside this big red mammal circle. So anything inside the circle is a mammal, and that includes these Labradors. Okay, now we're going to go to your notes page. You've got a nested Venn diagram at the top, and below we've got some vocabulary. So how about we get a red marker, and we start with the vocabulary. Natural numbers are also called counting numbers because they're numbers that we count with. Starting with the number, when you start counting, what do you start with? Okay, everybody count to 3. Ready? Go. I'm assuming you started with the number 1. So natural numbers are counting numbers starting with 1. So let's go ahead and take a moment, pause the video if you need to. You're going to need to. Let's outline the outer circle here. It looks yellow, but let's use orange. That'll show up real nice. And then your next circle in, let's do green. Oh, I'm sorry, gurn. And then the next circle in, we're going to do bleu. And then the smallest circle, let's do purple. So pause, take a moment, color that in. Okay, I'm assuming you've outlined all of your Venn diagrams with those fun colors. Okay, let's start writing. Now, when you write, let's go ahead and use like a either a pen or a pencil, something with a small tip so you don't get all clogged in there. Inside our first circle on the inside the purple circle, let's write natural numbers. Now, if you want to abbreviate numbers with a hashtag, that's fine. Just talking about the natural numbers. Those are the numbers that we count with, starting with 1. So let's make a list. 1, 2, 3, 8 divided by 2, 5, and 6.0. Now we threw in an improper fraction because what is 8 divided by 2? It's 4. You might see it in an improper fraction form, like that. Then we have 5, and then we have 6.0. So even though 6.0 has a decimal, its value is actually 6. So it's classified as one of the natural numbers. So it's basically any number that you can count to, no fractions, no decimals. All right, let's go to the next outer circle. We're going to the bleh circle. We're going to talk about whole numbers. A whole numbers is a non-negative and does not have a fractional part. Okay, so go ahead and get your pen or your marker and write in fractional. Okay, now think of all the numbers we just listed, the whole numbers. We had 1, 2, 3, 4, 5, to infinity and beyond. None of those had a negative. Can you think of another number that doesn't have a negative? How about 0? 0 is not a negative number, so it's considered a whole number. Okay, let's go back to our Venn diagram. And in our bleh circle, we're going to write whole numbers. Now, do you agree that all of these natural numbers are inside the whole numbers circle? They are. So, natural numbers are whole numbers too. 5 is a whole number, 6 is a whole number, all of these to infinity are whole numbers. But what is not included in the natural numbers was 0. So put that in the whole numbers. So your whole numbers include 0 and 1, 2, 3 all the way to infinity. The reason why 0 is not a natural number is because when you start counting, you don't start with 0. You start with 1. All right, we're on to the gern. What could that possibly be? They're integers. Okay, what the heck are integers? Well, it's all of their whole numbers. So go ahead and write down whole numbers. Okay, so it's all those whole numbers and their opposites. Yes, all the negatives as well. We've been doing integers for a few weeks now, and you're comfortable with positive and negative numbers. Those are the integers. All right, so in the gern circle, go ahead and write integers. Okay. 0 is an integer. It's inside the green circle. 1, 2, 3, 4, 5, and 6 are also integers because they're inside the green circle. Like the Labrador was a dog and it was a mammal. So natural numbers are whole numbers and integers. But what is not included in the whole and natural numbers are the negatives. So go ahead and write that down. -1, -2, -3, -8/2, -5, and -6.0. So even though it's got a 0.0, the 0 can drop off and the value is 6. All right. So this is everything we've been working with. Now we got one more set out in the orange. We are talking about rational numbers. Okay, rational numbers are any numbers that can be written as A over B. A is your numerator, B is your denominator. So if you can turn a number into a fraction, it is a rational number. But both A and B are integers. That means they could be positive or negative. But B cannot equal 0. Your bottom number cannot be 0 because you cannot divide by 0. If you ask Siri to divide by 0, they're going to say you're not dividing. If I was there, I would have Siri do that. But this is just a fancy way of saying rational numbers are fractions and decimals. Well, they're not just fractions and decimals. They include fractions and decimals. Ugh, I can't talk. All right, so write down fractions and decimals. And then let's go to the Venn diagram and write rational numbers. You can abbreviate numbers with the hashtag if you would like. Okay. Now, do you agree 1, 2, 3, 0, -1, -2, -3, all of those numbers, they're rational numbers too. They are. And I'll prove it to you in a little bit. But what is not an integer or a whole number or a natural number are all the ones that have decimals, like 0.4, -2.1, 2 1/5, -3/8, and 7/10. All of these are in fraction or decimal form. I cannot drop off the decimal, like the 0.1. I can't drop that off. It changes the value, like I did in the 6.0. So if there is a decimal that won't drop off, it's just a rational number. It's not an integer, it's not a whole number, it's not natural, it's just rational. Now, every number we've ever dealt with in here is a rational number. More specifically, we've been doing the integers, which were the negatives, 0, and the natural numbers. The whole numbers are 0, and the natural numbers are 1, 2, 3, 4, 5, and 6, to infinity. Okay. Is -1.5 an integer? Why or why not? If you need to pause to discuss, that's fine. And what I hope you realize is that -1.5 is not an integer because of the 0.5. Just because it has a negative doesn't mean it's an integer. That 0.5 makes it just a rational number only. Okay, now we're going to do this on the next video because I don't have a way to stop this and go to a different screen. All right, I'll see you on the next video.